So I asked you to, since we're now solving inequalities by multiplying and dividing, I asked you to read that first big sentence there and fill in the blanks. When using inverse operations of multiplication and division to solve inequalities, if you multiply or divide, what do you think that? By. If you multiply or divide by a, what kind of a number? No. Positive or negative?
Positive.
No. Negative. It's the negative that's a problem. Okay. So we didn't remember that from before, huh? If you multiply or divide by a negative number, what do you have to do to the direction of the inequality symbol?
Change it.
Change it. You have to flip it, reverse it. Let's say reverse. Reverse the direction of the inequality symbol. That's the only thing, just the B part. If it has the equal to bar, the equal to bar stays there. If it doesn't have the equal to bar there, it doesn't get put in there. All we're doing is reversing it from is less than to is greater than, or from is greater than to is less than. Okay? So the reason that, and this is really, you might want to make sure you have some good circles around that. By a negative number. That's important. Okay, don't let your brain go to, as soon as I see a negative number in an inequality, and I'm solving it, I have to reverse the symbol. Okay, because we aren't always going to. So let's do the first one here. Negative 3x is less than 27. What do we have to do to solve that? Tyler?
Divide by negative 3.
Divide by negative 3. So we have a negative 3x that's going to get divided by negative 3. And we have a 27 that's going to get divided by negative 3. So our negative 3's are canceling here, and we have our x. You have to stop now and think to yourself. You have to ask yourself this question every single time now. Did I multiply or divide by a negative number? What did we?
Divide.
We divided by a negative 3, so we have to reverse the symbol. And 27 divided by negative 3 is? Negative 9. Okay, and now we'll graph it. What neighbors live to the, what integer neighbor is closest to the left?
Negative 10.
Negative 10. What integer neighbor is closest to the right?
Negative 8.
Negative 8. What kind of a circle at negative 9?
Unfilled.
Unfilled, open, okay, and shaded
To the right.
to the right, because we need all the numbers that are greater than negative 9. Okay, now it is worth it today until you get so that you don't keep, not worrying about watching for that multiplying or dividing by negative. It is worth it to take a moment and just do some mental math checking. Pick a number from your shaded region, not the endpoint. Just pick a number from the shaded region. So give me a number from the shaded region.
Negative 7.
Negative 7. Okay. Put that into the inequality and make sure it makes it true. So negative 3 times negative 7. What is that?
21.
That's positive 21, isn't it? Negative 3 times negative 7 is positive 21. We're back in the original statement here. So we have 21 is less than 27. True or false? True. Now, what would have happened if we hadn't remembered to reverse the inequality symbol? We would have had x is less than negative 9. We would have shaded going to the left, wouldn't we have? Then we would have had negative, we could have said, well, let's check negative 10. So let's do that, mental math. Negative 3 times negative 10. 30. 30 is less than 27. True or false? False. So that right there, we should make you stop and say, I need to go back and look. Did I multiply or divide by a negative number? That might be where you're making your mistake. Or the other place you're making your mistake is you haven't figured out how to graph these correctly yet. Okay, it could be one or the other. So anybody have any questions? Okay, go ahead and do this next one on your own then. It's kind of like saying how many $1.50 are in $6. $1.50 twice is $3. How many $3 are there in $6?
2,
2, so we got
4.
2 times 2, we got 4, don't we? And a positive, or a negative divided by a positive is a negative, okay? Should I reverse the inequality symbol?
No.
Why not?
Not
Riley?
Because you didn't divide by
I didn't divide by a negative. We divided into a negative, but is that part of the rule? It's by, not into. Did we divide by? No, we did not, so we're not going to reverse the symbol. And we have our inequality statement with the variable on the right side now,
But we
instead of
could-
on the left side.
Could we switch it then?
Or we could switch it around. Do you mean the symbol or the statement?
The statement.
The statement, yes, we can switch this statement around, and it would, now what would it read, Aaron? X is
Less than or equal to.
less than or equal to -4. Okay, now make sure you're really not getting confused with, why did we reverse the symbol there? We didn't reverse the symbol in this one right here when Aaron said, could we have the variable on the left? We did not reverse the symbol because we multiplied or divided by a negative. Why did we reverse it?
To get the variable on the left.
Yeah, we have to flip it over. If we want the variable on the left, we had to reverse the order of everything. There's a difference between reversing order and reversing the inequality symbol because you're multiplying or dividing by a negative. So sometimes within a problem, you can reverse it twice. You reverse it once because you multiplied or divided by a negative, and you reverse it a second time because you like the variable on the left instead of on the right. Okay? So there can be 2 reasons to do it. Okay, let's graph this. Integer neighbor to the left,
-5.
-5. Integer neighbor to the right,
-3.
-3. What kind of a circle class at -4?
Filled.
Filled in, shaded in. And which direction should we shade?
To the left.
To the left. Okay. Okay. Let's do a quick mental math one again. Pick a nice number that's in that shaded region. Don't make this hard for us. It's a decimal we're going to be multiplying by. Give me a nice number to pick to multiply that 1.5 times. That's from our shaded region.
-6.
No, I don't like that number. I want a nicer one.
negative
10, thank you. Ken is -10. Wouldn't -10 be in our shaded region? Yeah, it's down there, over there. -10. Well, 10 times 1.5 is what? 15. We just move the decimal point 1 over. A positive times a negative is a negative. So we have -15. Is -6 greater than or equal to -15? Is -6 greater than -15? Absolutely. So I'm feeling pretty good about where we shaded. Okay, so anything we should talk about with that? Okay, let's see. Here's what you're going to be tempted to do. Because this looks like a proportion, doesn't it? But here's what a proportion is, you guys. Listen carefully. A proportion is one ratio equal to another ratio. Is this an equation?
No.
No, this is an inequality. We don't talk about proportions when we talk about inequalities. Because you know what? When we do cross products, how are we going to know whether we multiplied or divided by a negative properly? So we don't do that. So we do something else. We look at the side that the variable's on and say x is being
Divided by 6.
divided by 6. What undoes dividing by 6?
Multiplying by 6.
Multiplying by 6. So we're going to take both sides times 6. In both cases, we could make it into a fraction by putting it over 1, since we do have fractions on both sides. Okay, what can we do on the left side when we have 6 over 1 times -1/3? Fraction times a fraction. Can't we do some simplifying first? Okay, what goes into what?
3 goes into 6 twice.
3 goes into itself once, into 6 twice.
So 2 over 1.
So we have 2 over 1 times -1 over 1. We got 1s downstairs. We can forget about them now. We have a 2 times a -1 upstairs. What's that? -2. Did we multiply by a negative number? No. The number we took the 6 times was negative, but the 6 itself is not negative, so we did not multiply by a negative, so the sign stays the direction it was. And here these 6's cancel, and we have x. Also known as x is greater than negative 2. Okay? So how are we going to show that on a graph? Negative 2, integer neighbor to the left. Negative 3, integer neighbor to the right. Negative 1, open or close circle at negative 2. Open, which direction should we shade? To the right. All numbers greater than negative 2, or as the top one says, negative 2 has to be less than all the numbers in your shaded region. And it is. Okay. Let's go on to number 4. Negative x is less than negative 14. What do we have to do? Okay, well, what's really happening with that x? If it's a negative x,
Being multiplied by
it's being multiplied by negative 1. In reality, we could say this is really negative 1x is less than negative 14. And what do we do when x is being multiplied by a negative 1? We would divide by a negative 1. So these guys cancel. X is less than? Because we divided by a negative, and negative 14 divided by negative 1? Positive 14. There's our algebraic solution, and now all we have to do is graph it. Integer neighbor to the left, 13 to the right, 15. Open or close circle at 14, open and shaded to the right. Okay. Okay, let's just do a really quick check for this one. This is not going to be hard to do. Let's pick 15, since it's in our shaded region. We'll put 15 in for x, and what that really means then is we have the opposite of 15, which is negative 15. Is negative 15 less than negative 14?
Yes.
Yes, feeling good about that then. Okay. Okay, let's go to the back. Oh, these were always fun ones when we had equations too. I can hardly wait to do this. Because here's what you're going to want to do. You tell me first of all what's happening on the side with x.
It's getting
Getting multiplied by 2/3, which means to undo multiplying by something we need to divide by it, but we don't, typically we try to divide by a fraction, it doesn't work out always. So typically the best route to go is just to change it right away to, instead of dividing by that fraction, multiplying by its reciprocal. What is the reciprocal we need to multiply by then?
3 halves.
3 halves. It's 2/3 x, so that's the fraction we're concerned about getting rid of. And it just so happens that there is a fraction on the other side, and that fraction also has to get multiplied by our 3 halves. Okay. On this side, the 3's cancel, the 2's cancel, we have x. Do we reverse the symbol?
No,
Oh,
Why not?
because we didn't multiply or divide by a negative.
Okay, we multiplied by a positive, didn't we? 3 halves was positive, so we don't need to switch our symbol. Okay, can those 3's upstairs cancel each other out? No, one's going to be up, one's going to be down. Can that 2 go into that 4 on the bottom? No, one's got to be up and one's got to be down. So can we do anything to simplify before we multiply in this one? No, so we're going to say a positive times a negative is a negative. 3 times 3 is?
6, 9. No,
9.
9. 2 times 4 is? 8. Does 8 go into 9 nicely? No. So we're going to just say, this could also be renamed as what mixed number? So we know where we're at on the number line. 1 and 1/8, a negative 1 and 1/8. It's good to know where we're at on the number line. Okay, and then now we will graph using good number line sense. So sometimes you probably should put that tick mark in the middle right away, and this would be one of those times I'm thinking I don't wanna. Because I'm thinking that, what two integers is -1 and 1/8 gonna fall between?
1 and negative 1 and
-1 and -2. Let's do those guys first. And then decide where -1 and 1/8 should go. So which one should it be closer to?
1.
The -1. And so we're gonna say, okay, here's about a half, and then I gotta divide that into half, and then I gotta divide that into half again. I would say it's about right there. -1 and 1/8. Good number line sense. Good distance representing. Okay, open or close circle there? Closed. Shaded to the right. Okay. So that's a closed circle. I didn't do a very good job of making. I say, make sure I can tell what it is. No open air. Okay. Go ahead. We gotta write an inequality statement for this before we can solve it. 7 is no less than the quotient of x and 3. 7 is no less than, this is, you gotta be really careful when you're thinking about your, so this is right here what's gonna be your inequality statement, or inequality symbol. So, who wants to offer up what inequality symbol they think we are going to use there? Aaron?
It would be 7 is less than or equal to 3x.
Quotient?
Excellent.
Quotient means division, and division has fussy, it has to be in order. Okay, you guys agree with the symbol? 7 is no less than. Okay, let's just use a number. 7 is no less than. Give me a number 7 is no less than.
7.
8? Let's try 8.
6.
7 is no less than 8. Give me 6. 7 is no less than 6.
7.
Okay, so do you think we should change the inequality symbol here to is greater than or equal to? Yeah, I think it should be is greater than or equal to. You have to have a good start. 7 is no less than. In other words, it has to be greater than or equal to. No less than. Okay, and now what are we going to do to both sides to solve this?
Divide by 3.
Divide by 3?
Multiply by
Multiply by 3. Take both sides times 3. On the right side, I'm going to make it into a fraction, so I can see that I'm taking a fraction times a fraction. On the left side, we get 21. Do we need to reverse the inequality symbol?
Yes. No.
We did not multiply or divide by anything negative. Over here we have x, okay? Or what's the other way we could write this? X is less than or equal to 21. Go ahead and graph that because you don't need me to help you do that anymore.